Hello everyone, welcome to the YouTube channel of DCC NIT-A. So in this video we are going to discuss the problem Wooden Toy Festival, which came in Codeforces around 878 div 3. So in this problem there are 3 carvers who work in a workshop, and there are n people who come to the workshop with a request to make a wooden toy. Now let's denote the pattern of the toy that the ith person wants as AI. Now each of the carvers can choose an integer pattern x in advance, and different carvers can choose a different pattern. X is an integer here, and to make a toy of pattern y, for a carver who has chosen a pattern x, it will take modulus of x minus y time. Now the carvers can choose who will take the job, and they can also work for different people simultaneously. Now we are asked to find the best maximum waiting time the carvers can achieve to complete all the tasks. So this problem can be solved using binary search. We can binary search on the maximum waiting time and can find the required answer. Suppose the best maximum waiting time was 2 seconds. So if it is possible in 2 seconds, then it is obviously possible in 3 seconds and 4 seconds and anything above 2. But below 2 it is not possible. So we can use this fact to use binary search, find our answer. Now in binary search we will try to find out that for a given waiting time and given pattern y, what is the minimum and the maximum x that a carver can have. We will do this for every n item and try to find out the minimum and maximum x and that the carver can have. And after finding out all these ranges, we will try to merge this and check that finally how many ranges we are left with. If we have more than 3 ranges, then we can say that we will require more than 3 workers, and the time that we have selected in binary search is not possible, otherwise it is possible. So it will be more clear when you look at the algorithm. So let us take this last test case. So first of all we'll sort this array, because sorting will help us to find out these ranges and merging them efficiently. Because let's see, suppose the best maximum waiting time, let us take it as 1. So if we take it as 1, then for the first element, which is 3, for this we'll have the minimum x that a carver can have. It will be 3 minus 1 and 3 plus 1. So basically it will be either 2 or 3 or 4. So it will be in the range 2 to 4. Then similarly for 10, this will come as 9 to 11. And for 1, this range would be 0 to 2. So if this array was not sorted, then the data structure where we will be storing these ranges, we have to search for like when we will come to 1, we'll see okay, so this range is from 0 to 2. Then we have to search do we have any other number between 0 to 2 in our data structure, like this for the first element there is a range between 2 to 4, so we can merge this and then we will get the combined range as 2 to 2. So if it was sorted, then it would be very easy for us and it would be very efficient to merge these ranges. So it's better that first of all we sort this array and then start our binary search. So after sorting we will have this array. So it will look like this, and these are some variables for binary search: low, high and mid. And this small r and capital R will keep track of the range for a particular uh, index, and this is the overall range that we have tracked, just up to this index. And this counter will store that at max how many workers or carvers are required. So let us start the binary search and see how we proceed. So for this example, I am taking high as 17, but in original solution we will be using 1 into 10 to the power 9, as this was the constraint. But for this example, I am taking it as 7. So if this is low and this is high, so we'll get the middle as 8. So let us see if we take 8 as our answer, and this L and R as ranges. So can we get our answer or not? So the value of L here will be A of 0 minus mid. So A of 0 is 1 and mid is 8. So the value of it will be minus 7, and the value of R will be 9. So currently we are at first index, and for it A of I minus mid and A of I plus mid will be calculated as minus 7 and 9. So we can see it is exactly matching with it. So definitely our answer is going in the right direction. We can obviously have now here this L and R signifies that any worker who have chosen the X between minus 7 and 9 can finish this task, and means can complete this work which is present at this index. So let's proceed to the next index. So for the next index, we can see there is 3 and mid is 8. So for this index we'll have minus 5 as the lower limit and 11 as the right limit. So now we'll try to find what is common between in this range. So here minus 5 to 9 is the common range, so we'll reduce our overall range to minus 5 to 9. So this signifies that any worker whose chosen number X is between minus 5 to 9 can complete the first two tasks. So let's move to the next index, which is 10, and for it the lower limit would be 2 and 18. So let's see what is common here. So we can see that the common range here is between 2 to 9. So we'll reduce our range 2 to 9, and so this signifies that any worker whose chosen X between 2 to 9 can complete first 3 tasks. So let's move to the next index. So for this index, the lower limit would be 11 minus 8, which is 3, and the right limit would be 19. So again we try to find the common between these ranges. So we'll see that 3 to 9 is common, so we'll shrink our range and move to the next index. It's 15. So again we'll compute the L and R. So for 15 we'll have 7 and 26. So again we find common between them and reduce our L and R, means the range between L and R. So it will be from 7 to 9 this time, and yes, again we can see that any worker whose x is between 7 to 9 can complete these tasks, these many tasks, first 5. Let's move to the last index and let's calculate L and R. So for this, L would be 9 and R would be 25. So you can again shrink it and make our L to 9. So now we can see that any worker whose chosen x is between 9 to 9, means exactly it is 9, can complete all of the given tasks, and only one worker is enough. So now we can say that by choosing this 8 as our answer, we can clearly say that it is possible that 8 could be the maximum time that we are looking for. So now we'll reduce the search space and reduce the high to mid -1, so it becomes 7, and now our middle becomes 7 plus 0 by 2, which is 3. So now we have our mid as 3, and let us calculate the initial range L and R. So this would be A of 0, which is 1, minus 3, which is mid, so it will be -2, and this will be 1 plus 3, 4. So it will be for the initial element, it will be the same as this L and R, -2 and 4, as we have seen earlier. So entire range is common, so any x between -2 and 4, if a curver chooses, can complete this task. So now let's move to the next element, which is 3, and for 3 the L would be 0 and R would be 3 plus 3, 6. So again we try to find common between these two ranges, and we can see it is 0 to 4. So let it 0 to 4 and proceed further. For next element, which is 10, we'll do 10 minus 3, which is 7, and 10 plus 3, 13. So now we can see that there is nothing common between these two ranges. There is nothing common, so a single worker cannot complete all these 3 tasks. So now we need another worker. So we'll increase our counter, is the number of workers that are required, to 2, and we'll set our initial range as same as this third element, which is 7 and 13. So now let's proceed further. So the next element is 11, and for it L would be 8 and R would be 14. So now we can try to find something common between these two ranges, and you can see that the common is 8 to 13. So we change it to 8 and go to the next index, which is 15, and for 15 it will be 12 and 18. So again we can see the common between them is 12 to 13. So we'll shrink our range to 12 to 13 and go to last index, and for last index L would be 14 and R would be 20. So again we can see that there is nothing common between these two ranges. So we need another worker, so we'll increase our counter to 3 and we'll change this range to 14 to 20. So finally we can see that at most 3 workers are required to complete all the tasks if we choose 3 as our answer. So 3 is a possible answer. So now we'll again shrink our high to mid minus 1, which is 2. So when we have low as 0 and high as 2, we'll get mid as 1. So again start doing. So for 1 we have L as 1 minus 1, 0, and R as 1 plus 1, that's 2. So for the first element, as we have seen, it will be always same, and number of workers also will be 1. So we can proceed to next. So now for this element, the L will be 2 and R will be 4. So now we will try to find something common, and we can see the common range is 2 to 2. So let's move to next index, which is 10. Now here for 10, L would be 9 and R would be 11. So now we can see there is nothing common between them. So you can increase our number of workers to 2 and set our initial ranges at 9 and 11. Let's move to next index, which is 11. And for 11, L would be 10 and R would be 12. So the common between them is 10 to 11. So we'll shrink this range 10 to 11. And let's move to next index, 15. So for 15, L would be 14 and R would be 16. So again you can see there is nothing common between them, and we have to increase the number of workers. So it will be 3 again, and set them as initial ranges 14 to 16. Let's move to the final index, 17. And for 17 it would be 16 and R would be 18. So we can see there is common between them, which is 16 to 16. So finally we can see that we can also have 1 as our answer. So we'll again shrink our high to mid minus 1, which is 0. So now we have all our 3 variables low, high and mid set to 0. So let's calculate capital R, which will be 1, and capital R will be 1 itself. So it will be same as capital L and R as we have seen earlier, and the entire range is common. So we'll proceed to the next index. Now as we come to 3, we'll set this to 3 minus 0, 3 and 3 plus 0, 3. So you can see there is nothing common between these ranges. So we'll increase our work to 2 and set 3 and 3 as our L and R. So let's move to next index, which is 10, and it will be 10 minus 0, 10 and 10 plus 0. So you can see again there is nothing common, and we have to increase our workers to 3, and we will set this L and R to 10. Now let's move to next index, which is 11. So it will be again 11 and 11. So now we can see there is nothing common between them, and we have to increase our workers. So number of workers required becomes 4. But in the question they said that we have only 3 workers. So now we can say that by choosing 0 as our answer, we cannot 0 as a time we cannot have our answer. So now since we cannot have 0 as our answer, we have to increase our low to mid plus 1. So now low becomes 0 plus 1, which is 1. And now we can finally see that our low has crossed high. So we will stop our binary search here and we'll have 1 as our answer. So we can see for the last test case we have 1 as our answer. So now let's see the implementation. So first of all, we take the input for n, the entire array, and then we'll sort this array. Then we'll keep our low as 0 and high as 1 into 10 to the power 9. Then this binary search, low is less or equals to high. We'll calculate mid as low plus high by 2, and then we'll check that if this mid is possible as our answer or not. If not, we'll increase our L to mid plus 1, else high equals mid minus 1. Let's check this is possible function. So in this function we pass the array, the size of the array and mid, and we'll keep our counter as 1, and this is the same variables that we have seen in OneNote, as you can see this. So we have our capital L and capital R. So now we'll iterate over the entire array, and for each element we'll find out the range as AI minus mid and AI plus mid. And if there is something common between these ranges, which means this small l is less or equal to capital R, then we will shrink the range, or else we have to increase the counter is the number of workers. Now if counter reaches 4, means 4 workers are required, then you can clearly say it is not possible and return false from here. Or next we can set capital L and capital R as L and R. So if we do not return false from this loop, we will return true finally, means it is possible. So after all this, we will have our answer in our low, means in variable L, and we'll print this as our answer. So I hope you have understood the video and the explanation. So thank you for watching.